Hello, Algebra 2, and welcome to Lesson 7.2 on adding and subtracting rational expressions. This warm-up reviews Section 7.1, which is multiplying and dividing rational expressions. So go ahead and pause the video and try the warm-up, see if you can do these problems, and then we will go over the answers shortly. Okay, number 1 simplifies to -3RT. Number 2, make sure you change the division to multiplication by the reciprocal and you get ay squared over 10x. Number 3, once we factor everything and cancel out the common factors, we're left with 3b minus 1 over b plus 5. Number 4, once we factor everything and cancel out the common factors, it reduces to 2x plus 1 over x minus 4. Number 5 reduces to p over 8. And number 6 reduces to 4 over 3. Again, factor the expressions first and cancel out the common factors. So this lesson will help you with both sections of 7.2. We added and subtracted polynomials before. Now we're going to determine the LCM, which stands for least common multiple of polynomials, and then use that to add and subtract rational expressions. So the first example here is to find the LCM, or the least common multiple of 15a squared bc to the third, 16b to the fifth c squared, and 20a to the third c to the sixth. There's 3 terms, and what we want to do is factor these monomials using prime numbers. So 15, how can 15 be factored using only prime numbers? Prime factorization. 15 can be written as 3 times 5, and then times a squared b and c to the third. That would be the complete factorization using all prime numbers of the first monomial. What about 16b to the fifth c squared? Well, 16 can be 2 times 2 times 2 times 2. 2 is a prime number. Or 2 to the fourth times b to the fifth c squared. And then the third monomial, 20, can be factored into 4 times 5, but 4 is not a prime number, so we'll do 2 times 2 times 5, or 2 squared times 5, times a to the third times c to the sixth. Then, the least common multiple, we use each factor the greatest number of times it appears. So if you'll see, are there any other 3's? Nope, so we'll put a 3 down here. What's the biggest power of 2? 2 to the fourth, there's only one 5. What's the biggest a? A to the third. What's the biggest b? B to the fifth. And what's the biggest c? C to the sixth. So the least common multiple, if I multiply 3 times 5 times 2 to the fourth, is 240. So my least common multiple would be 240, a to the third, b to the fifth, and c to the sixth. Whenever we do this with polynomials, we want to, again, start by factoring each expression. X to the third minus x squared minus 2x, we can take out an x and then factor the leftover quadratic into x plus 1 times x minus 2. For x squared minus 4x plus 4, we can factor that into x minus 2 times x minus 2, or x minus 2 squared. Now that they're factored, we can just write each term the greatest number of times it appears. There's no more x's, so we'll write an x. There's no other x plus 1, so we'll write an x plus 1. And x minus 2 appears twice here. So our least common multiple would be x times x plus 1 times x minus 2 squared. Okay, now here's a problem for you to try. See if you can find the least common multiple of these 3 monomials. Go ahead and pause it if you need to, and then press play to see the solution. Okay, the final solution for this was 36, x to the third, y to the third, z to the second. Now try to find the least common multiple of these 2 polynomials. Pause it if you need to. And the answer is x times x plus 3 squared times x minus 1. And it doesn't matter what order you have these written in, but x plus 3 should be squared. Now, here we talk about how to add and subtract rational expressions using the least common denominator, or the least common multiple. And if you look at this closely, there's a little bit of a shortcut. If you see a over b plus c over d, ends up being ad plus over BD plus BC over BD. I'm going to show you a little bit of a shortcut that I call the butterfly method, which is what somebody called it for whenever we're adding and subtracting rational expressions to do it. Okay, so let's start with this first example. 5a squared over 6b plus 9 over 14a squared b squared. So the longer way to do it, and again, I'm not sure that it's really longer, but we want to find the least common denominator. So what's the least common multiple between 6b and 14a squared b squared? Well, the least common multiple of 6 and 14 is 42. And then we have a squared b squared. So we need to make each of those denominators be 42a squared b squared. So what do we need to multiply here to make this be 42a squared b squared? Well, we need to multiply it by 7a squared and then a b. And if we do it to the top, we do it to the bottom. What do we need to do here in order to make this be 42a squared b squared? Well, we already have the a squared b squared, so I think we just need to multiply it by 3, since 14 times 3 is 42, and if we do it to the top, we do it to the bottom. So once we have the LCD, and we multiply everything by 3, simplifying each numerator and denominator, again, just multiplying here, we're going to have 35a to the 4th b over 42a squared b squared plus 27 over 42a squared b squared. Now, since we have a common denominator, you might remember when you add fractions, you keep the denominator and you add the numerator. So it's 42a squared b squared on the denominator and 35a to the 4th b plus 27 in the numerator. And that's our final answer. Alternatively, if we use kind of like a cross multiplication, we see it's a plus sign, so we keep a plus sign. We can multiply across 5a squared times 14a squared b squared, and that gives us 70a to the 4th b squared. And then we can multiply the other cross product. 9 times 6b is 54b. And then we can multiply the two denominators together and put them on the bottom. 6 times 14 is 84a squared b to the 3rd. Now that might not look like our answer that we got down here, but if we factor both the numerator and the denominator by using the GCF, we can take out a b and we can take out a 2 from the top. And that leaves us with 35a to the 4th b plus 27. And if we take 2b out of the bottom, then we're left with 42a squared b squared. And we can now cancel out those two b's, leaving us with the exact same thing that we got when we simplified. So you need to decide if you want to multiply first and then it's already simplified, or if you want to use my little butterfly method of cross multiplication and then factor out the answer. Looking at this with polynomials, before you add or subtract polynomials, you want to make sure that everything is completely factored, especially the denominators. Let's factor the denominators by just using a GCF. 3x minus 15, we can take out a 3, leaving us with x minus 5. And with 6x minus 30, we can take out a 6, leaving us with x minus 5. So if you'll see our denominators, 3 times x minus 5 minus 6 times x minus 5. What's the LCD? Well, we could make it 6 times x minus 5. So all we'll have to do is multiply this first fraction by 2 over 2, giving us 2 times the quantity x plus 10 minus 3x plus 15. Be careful with the minus. Make sure we distribute the minus to both, over our LCD of 6 times x plus 5. We can use the distributive property on the numerator, giving us 2x plus 20 minus 3x minus 15, making sure we distribute the negative sign here. And then continuing, we can combine like terms. 2x minus 3x is negative x, 20 minus 15 is 5. And when we simplify this, if we take out the negative, we factor out the negative, then we can leave it as x minus 5, and then we can cancel it out with the x minus 5 on the bottom, leaving us with a final answer of negative 1/6. Alternatively, if we factor just like we did and we use our combining fractions method, we get x plus 10 times 6 times x minus 5 minus 9, 3 times 3 times x minus 5 times x plus 5 over the product of these together, which is 18 times x minus 5 and x minus 5. Now, we can factor these by taking out a GCF. These both have a factor of 3 and x minus 5 in them. So I'm going to take a 3 from the 6 and the 9 and an x minus 5, leaving me with 2 times x plus 10 minus 3 times x plus 5. And then on the bottom, I can also take out a 3 times x minus 5, leaving me with 6 times x plus 5, and then canceling out the common factors and distributing the numerator and simplifying like we did last time, we can end up with the same answer. So here's a problem for you to try. Go ahead and pause this, and then I will show you the answer. And the final answer is 18x to the third y plus 5 over 12xy squared. Go ahead and try this example here. Pause it if you need some time, and then I will go over the answer. And this simplifies to -1/4. Complex fractions are whenever you have a fraction within a fraction. We have 1 over a plus 1 over b over 1 over b minus 1. We want to clean this up. So what we're going to do is find the LCD of the numerator and the denominator. Well, the denominators in the numerator are a and b. So we're going to go with ab as our LCD. And then in the bottom, it's just going to be b. So we'll get it ready to add fractions. Again, you could do b plus a over ab and 1 minus b over b. Simplifying the numerator and the denominator, this would be b plus a over ab, and this would be 1 minus b over b. What we do next is we convert this into a division expression. So we take these two fractions, b plus a over ab, divided by 1 minus b over b. Then, to divide fractions, you multiply by the reciprocal. So it's going to be b plus a over ab times b over 1 minus b. We can cross-cancel the common factor of b, leaving us with b plus a over a times 1 minus b, or if you distribute the denominator, a plus b over a minus ab. Here's one for you to try. And this simplifies to b minus a over a plus b. If you have the same LCD, you can look at the whole thing as a whole. The denominators are x, y, and x. So we could make our denominator be xy, and we could multiply the entire fraction, the complex fraction, by xy over xy. So if I do xy times 2 divided by x, the x is going to cancel, leaving me with 2y. xy times -1 is -xy. xy times 1 over y, the y's will cancel, leaving me with x. And xy times 3 over x, the x's will cancel, leaving me with -3y. And that's my final answer. So here's one for you to try. See if you can multiply this by AB, both the top and the bottom, and see if you can come up with the correct answer of 3b minus 4a over 2a minus 1. Stuff starts to get a little bit complicated in this section, so please feel free to reach out with any questions. Also, search the internet and Khan Academy for videos. But let me know if you have any questions and need any help, and good luck.